Hello students, welcome to the session 15 on work energy power. So when we are looking at the head-on collision, so we are talking about particularly the perfectly elastic head-on collision. Okay, so already like in the previous session, right, when we're discussing about the perfectly elastic head-on collision, we are talking about the special cases. So one thing that we have discovered is the collision, if it is happening between particles of equal masses, the particles will actually interchange the velocities after the collision. So we are in the perfectly elastic of the head-on category. Okay, so what is it that we have seen in the previous class? V1 will become U2 and V2 will become equal to what? U1. They will simply interchange the velocities. That's the best example, like if you look at the billiard balls, right? One ball which is coming, it will hit another object which is at rest. Collision kapram, the first one will come to rest and the second one will start moving. Okay, so this is one of the very good example that we can consider to understand this perfectly elastic head-on collision between two objects of equal masses. Okay, so then we will go to the special case 2. So already we get the velocity expressions. So V2 and V1, we are looking at the collision between two particles or two objects. Okay, so generally if you are having the object, say particle 1, particle 2, the one that is coming with an higher value of the speed, or if the other one is at rest, so let's say for example the particle 2 is at rest, then we will call the particle 1 as what? We will call it as what? Projectile. Okay, so if the particle 2 is at rest, then the particle 1 is the one that is going to come and hit the particle 2. Okay, particle 2 will be called as a target. Okay, so if we are looking at a scenario where our projectile is the heavier one, massive projectile. So the mass m1, right, will be much higher in comparison to m2, and the target is a lighter one. So target and sonna, it is not like it has to be always at rest. It will be moving slowly. That is a very common way of using these words, projectile and then target. Okay, but main we are having a head-on collision, perfectly elastic category. In this, one of the particle is very heavy. Okay, so in we are looking at the one that is moving faster, that we are taking as the heavier one. The projectile is the massive. M1 value will be very high in comparison to M2. So if this is the case, right, if you look at this M2 by M1 ratio, M2 is very less, right? So M2 by M1 ratio, we can approximate it to 0. M2 by M1 ratio, we can approximate it to 0. How the velocities, the expressions will change with this assumption. What is the assumption? The assumption M2 by M1 ratio is approximately equal to what? 0. So that's first in the velocity formula in the M2 by M1 expression you are having this V2. Right side term, right, we will divide the numerator part as well as the denominator part by using M1 which will divide the numerator part as well as the denominator part. Okay, so divide what you are going to get M2 by M1 minus 1. A1 because M1 by M1 0 sorry, M1 by M1 is 1. 1 plus M2 by M1 into the U2 plus 2 times numerator M1 by M1 is what? 1 by 1 plus M2 by M1. So we are dividing both numerator as well as denominator by using M1 which we divide. Okay, so M2 by M1, we have to approximate it to what? 0. So approximate it to 0 means what we are going to get? So M2 by M1 we have to equal it to what? 0. So this is 0 this is 0 0. So what is it? 0 minus 1 by 1 plus 0, which is minus 1 overall. So minus 1 into U2 means minus U2 2U1 is there in the numerator. Denominator 1 plus 0 is 1. So v2, the lighter target oda velocity enadi, what is the velocity of the lighter target after the collision? v2 evla minus u2. So v2 is what? Minus u2 plus 2u1 is the v2 expression. Okay va? Apra we look at v1, the heavier massive projectile, adoda velocity after the collision. Adu eppadi varum parunga, same as it is. v1 expression edutittu we have to bring in this m2 by m1 kondu varanum. So adu eppadi parunga, so same as it is. We will take the v1 numerator denominator divide by m1. So 1 minus the m2 by m1 item divide by 1 plus m2 by m1 into u1. 2 times m2 by m1 into u2 divide by 1 plus m2 by m1. So what we will have to do? Enga the m2 by m1 varado, we have to equate it to what? 0 dana. So paranga inga m2 by m1 0 aidum. And the mother inga appadana 0 aidum. Idanadi 0. So paranga this is what? 1 minus 0 by 1 plus 0 means appadiye and the u1. Second term paranga numerator 0 varudhu. 2 times of m2 by m1, but m2 by m1 evla 0. So numerator 0 aidum. So the entire term will become what? 0. So veru u1 only will remain. Okay, so idhula oru important conclusion varudhu paranga enadhi, the v1 is what? v1 is the projectile which is the heavier one, massive. So the massive object oda velocity after the collision change agadu. Massive object oda velocity after the collision adanadi it will not be changing. What will be changing? Only the lighter target, adoda velocity mattum change agum. Okay va? So whenever you are having the perfectly elastic head on collision between two objects, one is a heavier one. In this case we are taking the projectile, the one that is coming faster, to be the heavier one. Collision ku appuram adoda velocity change agadu. The lighter target mattum it will be changing its velocity. Okay va? So the best example enna theriyuma, this is an unfortunate example also. Paranga, if you are having a lorry or a truck, the heavier mass, paranga 10 power 3 kg, it is coming and hitting a person on the bike. In the situation inga paatha, what is it? This is like the heavier or the massive projectile. Then this is the heavier or massive projectile. So this is object 1. This is the lighter target, object 2. Paranga m1, what is it? 10 power 3 kg is very high in comparison to 60 kg. Aprinda, what is going to happen? What is the conclusion we have got? v1 is equal to u1, means after collision and the truck oda velocity change agadu. Adu appadiye irukum. What is it? 120 km per hour. But what about the v2? v2 will be equal to what? Paranga, what is it that we got? v2 is equal to minus u2 plus 2u1. So minus u2 plus 2u1. Ingena theriyuma, we have to be careful about the sign convention. Like nama kinematics la panna madri, what you do? You take one direction to be positive, means other has to be taken as what? Negative. Ingena both these are in the same direction, right? u1 and u2 both are in the same direction. We take it as positive. Okay. So minus u2 means minus into 10 plus 2 times of u1. u1 evla 120. So what is it? Minus 10 plus 2 into 120 evla 240 dana. So idanadi 230 kilometers per hour. Paranga. So collision ku appuram the truck oda velocity change agadu, appadiye irukum, adu appadiye move aite varum. But the bicycle person, right, collision ku appuram with what velocity he will move forward? Paranga 230 km per hour. So like whenever there is an accident, right, the lighter object that will have the maximum impact. Like recently like in Gujarat or something, a car has hit a person and the person has gone onto the first floor of the building. Collision kapro, person is of course dead, but his body, right, it has gone to the first floor. Paranga. So that is the kind of an impact that collision with a heavy mass will have. Okay, wow. So this is what we are looking at, the projectile massive, one that it is hitting a lighter target. Okay va? So this is the special case 2. இதுக்கு exactly opposite என்ன வரும் பாருங்க. What is the thing that will have exactly opposite? That is our special case 3. என்னது? We have the projectile. This is a lighter one and the target, அதுக்கு initial velocity இருக்கலாம், the target will be the heavier one. So m2 oda value will be very high in comparison to m1. இதுக்கு ஒரு best example என்ன தெரியுமா? Look at this. You have a ball or something which we are dropping onto the ground. இங்க பாருங்க, this is like our projectile which is the lighter. Ground is the target, that is the heavy. Ground is the target which is the heavy. Okay, so இங்க பாருங்க, what is going to happen here? m1 oda value is very small in comparison to m2. So இங்க என்ன தெரியுமா? If we look at the ratio of m1 by m2, m1 is very small, so m1 by m2 can be approximate to what? 0. m1 by m2 can be approximate to what? 0. Okay va? So இப்ப பாருங்க, what is it that we are going to get? Actually என்ன ஆகும்? We are going to get, அங்க நமக்கு எப்படி வருது expressions, we are going to get just the reverse of it. So whatever the expressions we got before, right, இங்க என்ன வரும்? Just the reverse of it. Okay, so we can even write down the expressions before itself. So பாருங்க, which is the heavier one? m2 is the heavier one, right? So அதோட velocity change ஆகாது. So v2 will be equal to அப்படியே u2. v2 value will not be changing, right? v2 will be equal to what? u2. And v1 exactly அங்க நமக்கு என்ன மாதிரி expression வருது? We will have to repeat it. So v1 will be equal to what? Minus u1 plus 2u2. v1 ஓட வேல்யூ என்ன வரும் பாருங்க, minus u1 plus 2u2. பார்க்கலாம் எப்படி வருதுன்னு சொல்லிட்டு. But we can even write down these values by looking at the previous expression. Okay, பாருங்க, first நம்ம v2 solve பண்ணலாமா? So v2 இங்க நமக்கு என்ன வரணும்? இந்த expressions குள்ள m1 by m2 வரணும். So அதனால என்ன, we will divide the expression numerator and denominator by using m2. m2 வச்சு நம்ம divide பண்ணலாம். பாருங்க, so m2 வச்சு நம்ம divide பண்ணா what is going to happen? 1 minus m1 by m2 divided by m1 by m2 plus 1 into the u2. 2 times m1 by m2 into u1 by m1 by m2 plus 1. இங்க பாருங்க, so எங்க நமக்கு அந்த m1 by m2 வருது, we have to equate them to what? 0 தானா? அப்படி நம்ம 0 equate பண்ண என்ன ஆகும்? இது 0 ஆயிடும், அந்த மாதிரி இது 0 ஆயிடும், இது 0 ஆயிடும். so பாருங்க, first term என்ன இருக்கா? 1 minus 0 by 0 plus 1 into u2, that is what? அப்படியே u2. second term என்ன பாருங்க, numerator 0 வருது, so the entire second term is going to become 0. so check பண்ணுங்க, v2 ஓட value will be equal to what? u2. so எது ஹெவியா இருக்கோ அதோட velocity change ஆகாது. இதுக்கு முன்னாடி கேஸ்ல என்ன, the projectile is heavier one like the lorry. இங்க என்னது? the target is the heavier one like the ground here. the ground ஓட velocity change ஆகாது. but what will be changing? the velocity of the projectile. so இங்க என்னது? projectile is the lighter one. so எப்படி வரும் பாருங்க, v1 already நம்ம கிட்ட expression இருக்கா, similar formula, right? so v1 எப்படி வருது பாருங்க, what is v1? இங்க அந்த மாதிரி தான், like we have to divide by using m2. divide பண்ண என்ன வரும்? m1 by m2 minus 1 by m1 by m2 plus 1 into the u1 plus 2 times m2 வச்சு நம்ம divide பண்ணணும். so numerator m2 by m2 means 1 தானா? பாருங்க, so m1 by m2 is 0. இது நம்ம அப்படியே 0 equate பண்ணணும். so பாருங்க, first expressionல 0 minus 1 by 0 plus 1 into u1, that is minus u1. second expression என்ன, numerator 2u2 இருக்கு, denominator 0 plus 1 which is 1 as it is. so அங்க நமக்கு எந்த மாதிரி expression இருக்கோ அதுக்கு exactly reverse வரும். ஓகேவா? so this is what we have as the collision of a light projectile with a heavy target. heavy target oda if a light projectile is hitting it, right, அப்ப என்ன நடக்கும்? target oda velocity change ஆகாது, வெறும் அந்த projectile oda velocity மட்டும் change ஆகும். ஓகேவா? so இதுல ஒரு special discussion என்னன்னா, like in this case, right, இங்க பாருங்க, the heavy target can be at rest. the heavy target can be at rest means u1 oda value can be 0. so if the heavy target, right, is at rest, u1 கிடையாது u2. okay, so if the heavy target is at rest, our target is what, 2, right? So the heavy target is at rest, u2 oda value என்ன 0. இப்போ பாருங்க, if u2 is equal to 0, right, நம்ம கிட்ட expressions என்ன இருக்கா, v2 is equal to u2 அப்படிதானா, அதுக்கப்புறம் v1 is equal to minus u1 plus 2u2, அது நம்ம கிட்ட இருக்குது. So u2 is 0 means v2 also will be 0. v1 எவ்வளவு பாருங்க, u2 நம்ம 0 substitute பண்ணா v1 is equal to minus u1. So v1 will be what, minus u1, and v2 எவ்வளவு 0. So இதுக்கு என்ன தெரியுமா, like if you are having a ball which is colliding with the ground, இது நம்ம ஒரு perfectly elastic head on collision மாதிரி எடுத்தா, what is it that we are going to observe, collision க்கு அப்புறம் the ball is going to, இப்போ before the collision it is coming down, collision க்கு அப்புறம் it will start going up with the same velocity but opposite direction. So பாருங்க, v1 is equal to what, minus u1 means u1 எப்படி இருக்கும், downwards. So v1 will be upwards. Value wise ரெண்டு சேம் தான் இருக்கும், value wise both will be same, but direction எப்படி, before the collision it will be coming down, after the collision it will be going up. Okay va? So this is how we will have the collision of a lighter projectile with a heavy target. Okay va? So இதுல இந்த case 2 ஆகட்டும் or case 3, so ரெண்டுத்துல என்ன தெரியுமா, the heavier one is not going to change the velocity, அதோட velocity change ஆகாது, lighter one ஓட velocity மட்டும் change ஆகும். Okay va? So these are the special cases for the perfectly elastic head on type of collision. So பாருங்க, one question, a ball moving with a velocity of 2 meter per second towards a heavy wall which is moving towards the ball with 1 meter per second as shown in the figure. இந்த figureல காமிச்ச மாதிரி. So இங்க பாருங்க, ball, இது நம்ம particle 1 எடுக்கலாமா, this is our 2. So ball is the lighter. Okay va? This is what, heavy. So collision க்கு அப்புறம் என்ன, what is the thing that we know, the heavier oda velocity change ஆகாது, whatever is the heavier body, right, அதோட velocity change ஆகாது. What will be changing, only the velocity of the lighter one will be changing, அப்படிதானா, velocity of the lighter one will be changing. So பாருங்க, so if you look at it, right, collision க்கு அப்புறம் the heavy object ஓட velocity change ஆகாது, அது அப்படியே இருக்கும், the lighter object ஓட velocity மட்டும் change ஆகும். So இங்க பாருங்க, this is like, you know, a lighter projectile hitting a heavy target மாதிரி. Okay, so the v2 will be equal to u2 அப்படியே இருக்கும். So assuming the collision to be elastic, find the velocity of the ball immediately after the collision. Collision க்கு அப்புறம் we have to find the velocity of the ball. இங்க என்ன தெரியுமா, because we have to take care of the sign convention part. பாருங்க, so the velocity of the ball is towards the right side, ball எப்படி இருக்கா, left side. So we will take the right side to be positive, left side எப்படி, negative. So u1 it will be what, 2 meter per second. அந்த மாதிரி u2 எவ்வளவு பாருங்க, minus 1 hour. Why? Because sign convention is it will be negative. Okay, நமக்கு என்ன வேணும், v1 வேணும். What is the v1 formula? What is the v1 formula? Minus u1 plus 2u2, அதுதானா. What is the v1 formula? Minus u1 plus 2u2. So means minus u1 means what, minus into 2 plus 2 times of u1, total என்னது, minus 2 minus 2, totally minus 4. That's the v1 value. Means minus or significance enna, that it is telling it is going to move to the left side. It is telling what it is going to move towards the left side. So paranga, the ball after collision it is going to move to the left. That velocity value, what is the magnitude, 4 meter per second. It will be moving towards the left with 4 meters per second. Adanala sign convention wise we are saying it as what, minus 4. Okay va? So if you remember those expressions means நம்ம இப்படி சால்வ் பண்ணலாம். இல்ல we are not remembering those expression வெச்சுக்கோங்க. So we are not remembering those அந்த v1 formula நமக்கு ஞாபகம் இல்லனா, what is the other alternative, டக்கு நம்ம எக்ஸாமினேஷன் குள்ள உட்கார்ந்து. So we are not able to remember what is that expression for the velocity v1. அப்ப நம்ம என்ன பண்ணணும், அப்ப என்ன தெரியுமா, at least remember that இந்த மாதிரி collisions என்ன ஆகும், if you are having a lighter object and heavy object colliding, the collision க்கு அப்புறம் heavy object ஓட velocity change ஆகாது, அது மட்டும் if you are able to remember, right, then you can solve the problem. எப்படி தெரியுமா, look at this, the heavy object ஓட velocity change ஆகாது. So அந்த மாதிரி like, you know, what is it that we have, u1 is equal to 2 meter per second. Okay, u2 எவ்வளவு, minus 1 meter per second. heavy object velocity change agadu means v2 is equal to what? Same, v2 is equal to u2. நமக்கு என்ன வேணும்? v1 வேணும். இது என்னது? head on type perfect elastic தானா, which means coefficient of restitution oda value is 1. What is the coefficient of restitution value? 1, which means the velocity of separation after the collision, relative velocity of separation, which is v2 minus v1 will be equal to what? Relative velocity of the approach, u1 minus u2. And because e oda value another 1. Already we got the answer for this question, but and நம்ம derive பண்ண result உங்களுக்கு ஞாபகம் இல்லைன்னா what is it that we can do? We can at least remember that ஒரு heavy object ஒரு lighter object இருந்தா when you have a collision, right, heavy object oda velocity change ஆகாது. அந்த கான்செப்ட் வச்சுட்டு we can again get the answer by using the coefficient of restitution. எப்படி பாருங்க? So coefficient of restitution உள்ள 1 நமக்கு தெரியும். So which means the relative velocity of separation after collision v2 minus v1 is equal to what? The relative velocity of the approach before collision, அதாவது u1 minus u2. So பாருங்க, v2 எவ்வளவு? minus 1 minus v1, இந்த v1 தான் நமக்கு வேணும், is equal to u1 2 minus u2. இப்போ நமக்கு v1 தானே வேணும். So minus 1 minus v1 is equal to right hand sideல பாருங்க, that is 3. அப்படியே நம்ம rearrange பண்ணா what you are going to get? 3 left sideல வந்தா it will become what? minus 3. So minus 1 minus 3 is equal to v1. பாருங்க, what is it? minus 4. Minus oda significance enna? Direction part, that leads towards the left side. Okay va? So even if you don't remember that and நம்ம derive பண்ண formula ஞாபகம் இல்லைன்னா we can at least use the concept that heavier mass oda velocity change ஆகாது. அந்த கான்செப்ட் வச்சிட்டு using the coefficient of restitution we can solve this question. Okay va? So this is about the special cases in the edula the perfectly elastic scenario in the head-on type of collision. After that, we will go to the inelastic head-on collision. So inelastic and so now what is going to happen? The kinetic energy is not going to be conserved. The kinetic energy conserved. But any collision, right? We can use the conservation of momentum principle. We can always use the conservation of momentum. So same, we are having a particle m1 with a velocity u1, m2 with a velocity u2. They are having a head-on collision vechkonga. Then we can apply the conservation of momentum. What is it? m1 u1 plus m2 u2. Total momentum before the collision is equal to total momentum after the collision. Okay, so v1 and v2 are what? The particles oda velocities after the collision. But enna theriyuma inga enadhi, because in the elastic head-on la we got two equations. One equation coming from the conservation of momentum, ரெண்டாவது coming from the conservation of kinetic energy. But inga adu varadu, ஏன்னா we will not have kinetic energy conserved. அப்ப என்ன தெரியுமா? We should know the information about the coefficient of restitution. And the coefficient of restitution oda value நமக்கு தெரியணும். தெரிஞ்சா அதுல இருந்து we will be able to get the second equation. பாருங்க, second equation எப்படி வரும்? Second equation here in case of the inelastic head-on collision la second equation எப்படி வரும்? It will come from the coefficient of restitution formula la irundhu. பாருங்க, what is the coefficient of restitution formula? Relative velocity of separation collision ku appuram, which is v2 minus v1 by relative velocity of the approach before the collision, adanadi u1 minus u2. So நீங்க cross multiply பண்ணா என்ன வரும் பாருங்க? Cross multiply பண்ணா what is it that you are going to get? E into u1 minus E into u2 is equal to is equal to v2 minus v1. This is the second equation. So first equation engalanda varudhu? Conservation of momentum as it is, because conservation of momentum will be there for any type of collision. Second equation enna? It is the equation coming from the coefficient of restitution oda value. Ipo enna theriyuma, இந்த E value நமக்கு தெரிஞ்சதா we will be able to proceed. For an head-on inelastic collision, E oda value will be between 0 to 1. For the head-on elastic, what is the E oda value? 1. But inga enna theriyuma, it will be between 0 to 1. Okay, so 0 to 1 anu sonna adadi significance parunga. The numerator value, relative velocity of separation after the collision, will be lesser in comparison to the denominator. And the E value நம்ம less than 1 சொன்னா what is it? The numerator value, relative velocity of separation after the collision, will be lesser than relative velocity of the approach before the collision. Okay va? So இது நீங்க ஞாபகம் வச்சுக்கோங்க. What is it? E oda value will be between what 0 to 1. Okay, so in the ரெண்டு expressions which like நம்ம அந்த இதுக்கு முன்னாடி பண்ண மாதிரி we can derive the velocities of the particles after the collision. The v1 v2 values நம்ம derive பண்ணலாம் same as it is. என்ன பண்ணணும், say for example in the second equation வந்து take the value of v2 ஆகட்டும் or v1 எடுத்துட்டு substitute in the first equation. ஓகேவா, அப்படி பண்ணா we are going to get the velocities of the particles after the collision. So v1 and v2 expressions வரும். என்ன தெரியுமா, நீங்க க்ளோஸா அப்சர்வ் பண்ணா you able to see the similarity between this formula and the previous formula. இங்க பாருங்க, previous formula என்ன இருக்கா, what is it, v1 will be equal to what, m1 minus m2 by m1 plus m2 into u1, okay, plus 2m2 by m1 plus m2 into u2. இதுதானா, this is what we had previously. இங்க பாருங்க difference எங்க வருது, the m2 அதோட இடத்துல we are getting what, e times of m2. அந்த மாதிரி இங்க பாருங்க 2m2 க்கு பதிலா what you are getting 1 plus e times of m2. ஓகேவா, so what is it we are getting, the m2 ஓட பிளேஸ்ல what is it that we are having, இங்க என்னது m2 க்கு பதிலா we are getting e times of m2. 2m2 க்கு பதிலா what you are getting 1 plus e times of m2. that's the difference. Okay, and same v2 ஓட expression அப்படிதான், அங்க என்ன வரும், change will be coming in the m1 place. So what is the v2 formula, what is the v2 formula, we remember v2 will be equal to what, m2 minus m1 by m1 plus m2 into u2 plus 2m1 by m1 plus m2 into u1. இதுதானா, இங்க பாருங்க இங்க change எங்க வரும், m1 placeல வரும். Okay, so in place of m1 we will get e times of m1. 2m1 க்கு பதிலா என்ன வரும், 1 plus e into m1 வரும். ஓகேவா, அதுதான் டிஃபரன்ஸ். இங்க என்ன தெரியுமா, வேணும்னா you can remember these expressions, இல்லைன்னா பரவாயில்ல, at least in our NEET examination, right, நமக்கு என்ன we will get some simplified terms which the questions வரும். So even if you don't remember these, இந்த ரெண்டு expressions நமக்கு ஞாபகம் இல்லைன்னா பரவாயில்ல, because we can solve these questions by using these two formulae, இந்த conservation of momentum அதுக்கப்புறம் e ஓட வேல்யூ, அந்த ரெண்டு எக்ஸ்பிரஸ் வச்சுட்டு we can solve the question as it is. Okay, but if you are able to remember the formulas means that is also fine. Okay, it is up to you. So either நீங்க அந்த formulas you try to remember, இல்லைன்னா you can even solve the questions from those original equations. Original equation சொன்னா what is it, the conservation of momentum equation, அதுக்கப்புறம் the second equation என்னது, e ஓட expression. ஓகேவா, so இதுல இன்னொரு category of questions என்ன தெரியுமா, like one category of questions will be they will ask us collision க்கு அப்புறம் what will be the velocity of the particles, அப்படி கேட்கலாம். இங்க என்ன, they will ask us what is the loss of kinetic energy. Loss of kinetic energy சொன்னா what is it, the initial total kinetic energy ஓட value minus final kinetic energy. அதுதானா, so initial kinetic energy சொன்னா what is it, half m1 u1 square plus half m2 u2 square. Final kinetic energy means what, half m1 v1 square plus half m2 v2 square. So either if you are substituting this v1 and v2 value, இங்கல இருந்து அந்த v1 and v2 எடுத்து நீங்க substitute பண்ணா we are going to get a simplified expression. இதுவே நம்ம derive பண்ண போறது கிடையாது, just we can look at it like a result. இது எப்படி வருது, இங்கல இருந்து அந்த v1 and v2 value எடுத்துட்டு we have to substitute பண்ணா final expression என்ன வருது பாருங்க, half times m1 into m2 by m1 plus m2 into 1 minus e square into u1 minus u2 the whole square. So what is it paranga, half into m1 m2 by m1 plus m2 into 1 minus e square into u1 minus u2 the whole square. இது எப்படி வரும், when you substitute in the kinetic energy loss expression la v1 and v2 values நம்ம substitute பண்ணா we will get this expression. இங்கேயும் அதுதான், like either you remember this expression இல்லைன்னா depending upon the problem, right, ஏன்னா நம்ம இத்தனை expressions நம்ம memorize பண்ண முடியாது. So depending upon the problem, அவங்கள கொடுத்த scenario base பண்ணி see we are able to get in the ரெண்டு expressions use பண்ணி we are able to solve v1 and v2 வெச்சுக்கோங்க. Then as it is we can go for the original formula. And the original formula வச்சு we can calculate what is the loss of kinetic energy. What is the original formula meaning? Original kinetic energy half m1 u1 square plus half m2 u2 square minus the kinetic energy after the collision. Okay va? So either you remember these expressions, v1 expression, v2 expression and the மாதிரி the loss in kinetic energy, அது ஒரு scenario. இல்லைன்னா we use the original and the original expressions equations தெரியுமா conservation of momentum E ஓட formula அந்த ரெண்டு equations யூஸ் பண்ணி we can calculate V1 and V2 V2 வந்தனா we can use them to calculate what is the loss of kinetic energy அப்படியே பண்ணலாம் okay so this is about the inelastic head on type of collision okay வா so இதுல ஒரு special case என்ன தெரியுமா the rebounding of the ball after collision with the ground so பாருங்க what are we talking about here say for example you are having a ball which is colliding with the ground இதுக்கு முன்னாடியே we have discussed about the scenario right அங்கனா we said it is a elastic collision னு சொல்லிட்டு but practically என்ன நடக்கும் the collision க்கு அப்புறம் the ball will come only to some lesser height அப்படிதான் நடக்கும் so நீங்க ஒரு ball drop பண்ணா what you are going to observe the first collision க்கு அப்புறம் it will come to only some lesser height அதுக்கு அப்புறம் it will go down திருப்பி second collision க்கு அப்புறம் it will come to even lesser height அப்படிதானா அப்படியே அந்த height decrease ஆயிட்டே போகும் the height to which it will come keeps decreasing okay and after some time we will see almost the bouncing will become negligible okay so we will see how this is the case of inelastic head on collision then it is the case of the inelastic head on collision okay va so inga parunga the ball that we are dropping right let us say நம்ம ஒரு h0 height ல இருந்து drop பண்ண வெச்சுக்கோங்க okay so horizontal floor ல இருந்து we are measuring a height h0 அங்க இருந்து we are dropping it நம்ம அங்க இருந்து drop பண்ணா what is the velocity with which it will strike the ground kinematics right நீங்க ஒரு h0 height ல இருந்து drop பண்ணா what is the final velocity root 2gh தானா final velocity value என்ன root 2gh so it will be what root 2gh0 so the collision collide ஆகிறதுக்கு முன்னாடி what is the velocity of the ball it will be root 2g into h0 okay collision க்கு அப்புறம் let us say the velocity is v1 னு வெச்சுக்கோங்க v1 is what the velocity after first collision க்கு அப்புறம் the velocity is what v1 okay so இப்ப பாருங்க what is the e value the relative velocity of separation so இப்ப இங்க என்ன தெரியுமா this is the target which is always at rest so collision க்கு அப்புறம் பாருங்க the ball will be going up with a velocity v1 so relative velocity of separation னு சொன்னா what is it v1 collision முன்னாடி என்ன the ball is coming and approaching the ground with a velocity v0 அதுதானா so relative velocity of approach னு சொன்னா that is v0 so இங்கல இருந்து என்ன வரும் v1 ஓட வேல்யூ வரும் what is v1 e times of v0 so velocity of the ball after the first collision what is it v1 ஓட வேல்யூ என்ன it will be what e times of v0 okay so on the v1 velocity base பண்ணி it will go to a height h1 வெச்சுக்கோங்க what is the height h1 it is the height the ball will go after the first collision okay so இங்க பாருங்க same what is the h1 ஓட வேல்யூ v1 square by 2g அதுதானா and if you are giving a velocity u means up to what height it will go u square by 2g kinematics relations இங்க பாருங்க v square ன்னு சொன்னா what is it u square into v0 square by 2g e square into what is v0 square what is it e square into h naught so paranga what are we getting and the first collision க்கு அப்புறம் what is the height to which it will go to a height which is equal to what e square times h naught okay va what is the velocity value என்ன velocity after the first collision எவ்வளவு e times of v0 and what is the height e square times h naught okay va next we look at what will happen after one more collision so one more collision க்கு அப்புறம் என்ன ஆகும் பார்க்கலாம் so second collision அங்க என்ன தெரியுமா so second collision ன்னு சொன்னா the ball will be coming down with the velocity v1 collision க்கு அப்புறம் it will have velocity v2 so அப்ப இந்த ரெண்டுல what will be the relation e is equal to what v2 by v1 தானா we are looking at the second collision time so இதுல இருந்து v2 is equal to what e into v1 e into v1 means what e into v0 so என்ன வருது e square into v0 so பாருங்க the velocity of the second collision எவ்வளவு E square into V naught. Second collision kappuram, what is the velocity? It will be what? E square into V naught. Okay. In the V2 velocity, if it is going up to a height h2, by using the velocity V2, if it is going up to a height h2, then what is the h2 formula? h2 V2 square by 2g, same u square by 2g formula. V2 square means E square into V naught whole square by 2g. Okay. It will be what? E square whole square into V naught square. V naught square means, so what is it? H2 evada. It will be E square the whole square into H naught. Adanadi, this is our height to which it will go after the second collision. இப்படியே நம்ம கண்டினியூ பண்ணா பாருங்க, we will just do one more step. அதுக்கப்புறம் we will write the general formula. ஏன்னா general formula நமக்கு important. இங்க என்னது, we have to write one more step. அதுக்கப்புறம் we will be able to see what will be the general formula. So third collision சொன்னா என்னது, it will come down with a velocity v2. அதுக்கப்புறம் this is the third collision. So எங்கன்னா v3 by v2 is equal to e. So v3 is equal to what? E times of v2. So பாருங்க, v3 is equal to what? E times of v2 means E times of v2 evada? E cube into v naught. So we will be able to get that idea, right? So first collision kappuram, what is it? E into v naught. Second collision kappuram, e power 2 into v naught. Third collision kappuram, e power 3, which means nth collision kappuram enna irukum? What will be the velocity? This is the important result. What is the velocity after the nth collision? Nth collision kappuram, what we will have? It will be what? E power, அப்படியே நீங்க போனா what is it? Velocity after the nth collision will be what? E power n into v naught வரும். E power n into v naught. ஓகேவா? அந்த மாதிரி நீங்க height பாருங்க. What is h3? It will be what? v3 square by 2g தானா? So v3 square means e power 3 into v naught square by 2g. That is what? E power 3 whole square into h naught. So nth collision kappuram enna theriyuma? hn will be equal to what? E power n whole square into h naught. We can also write it like what? E power 2n into h naught. Appadi nam eludala. So nth collision kappuram, what is the height to which it will go? E power 2n into h naught. Okay va? So this is the important result for the rebounding of the ball after the collision. So inga parunga, the final results enna? Nth collision kappuram, the velocity of the ball will be what? E power n into v naught. V naught is what? The velocity with which it is striking the ground for the first time. Okay. Nth collision kappuram, what is the height to which it will go? E power 2n into h naught. Nth collision kappuram, what is the height to which it will go? It is nothing but what? Whatever the velocity it is having after the nth collision, that a square value divided by 2g. Like if you are throwing an object with a velocity u means, it will be what? H is equal to u square by 2g dana. So adalandi we will get what? The height to which it will go after the nth collision adavala e power 2n into h naught. So these formulas are important. Okay. So this is about the rebounding of the ball after the collision with the ground. So again we have discussed about the inelastic collision in the head-on type. So paranga, these are the kind of questions we can expect. So 2010 la vandhathu. This question has come in the year 2010. Ingana a ball is moving with a velocity 2 meter per second, collides head on with another stationary ball of double the mass. So it is colliding with a stationary. So paranga, so idoda m 2 meter per second vechukonga. It is colliding with a 2m which is at rest. So u1 evala 2 meter per second, u2 evala 0. Okay. If the coefficient of restitution 0.5, e value kuduthirukanga, what is it? 0.5, then their velocities after collision will be, the particles oda velocity nama calculate panna. So eppadi theriyuma, like already we have got these expressions for the v1 and v2. Na sonna madri, either you remember these expressions, idhula enna pananum, appadiye neenga and m1, so m1 is equal to what? M2 is equal to what? 2m. ஏன்னா அந்த வேல்யூஸ் கேன்சல் ஆகிடும். ஓகே, ஸோ m1 m2 அதுக்கப்புறம் u1 and u2 தென் ஈவோட வேல்யூ நீங்கள் அதில் சப்ஸ்டியூட் பண்ணால் we will be able to calculate what is v1 and v2. அது ஒரு அப்ரோச். இல்லை we are not able to remember these expressions means அப்போ நம்ம என்ன பண்ண பாருங்க, we will go with the original approach. நான் சொன்ன மாதிரி ஒரிஜினல் அப்ரோச் என்னது, ஃபர்ஸ்ட் conservation of momentum principle பாருங்க. the particle 1 is having a velocity 2, so m into 2. அதுக்கப்புறம் particle 2 is at rest initially is equal to final momentum. Final momentum means m into v1 plus 2m into v2. இங்க பாருங்க, what is this, m into 2 is equal to m into v1 plus 2m into v2. இதில் m கேன்சல் பண்ணலாம். என்ன வரும், 2 is equal to v1 plus 2v2. இதன் ஈக்குவேஷன் 1 வச்சுக்கோங்க. 2 is equal to what, v1 plus 2v2. அது ஒரு ஈக்குவேஷன். கன்சர்வேஷன் ஆஃப் மொமெண்டம் வந்து வருது. ரெண்டாவது, it will come from the coefficient of restitution தானா. what is coefficient of restitution formula, v2 minus v1 by u1 minus u2. u1 எவ்வளவு 2, u2 எவ்வளவு 0, so which is 2. cross multiply பண்ணா what will get, 2 அந்த பக்கம் போனா it will go to the numerator. 2 into 0.5 எவ்வளவு 1, which means v2 minus v1 அதனது it is coming as what, 1. v2 minus v1 எவ்வளவு 1. ஓகேவா, so this is our second equation. so நம்ம கிட்ட என்ன இருக்கா, we are having two equations. எத்தனை unknowns இருக்கா, 2 unknowns, v1 and v2 தானா, these are the two unknowns. okay, so இங்க என்ன தெரியுமா, we are not going with the formula approach. if you are able to remember the formula means அப்படியே அந்த formulas குள்ள நீங்க substitute பண்ணி you can calculate. but இங்க என்ன, we are going with the original approach. conservation of momentum principle ஒன்னு, ரெண்டாவது the coefficient of restitution formula. இங்க பாருங்க, what are the two equations we are having, v1 plus 2v2 is equal to 2. அது ஒன்று. ரெண்டாவது v2 minus v1 is equal to 1. நீங்கள் அந்த ரெண்டு ஈக்குவேஷன் அப்படியே ஆட் பண்ணுங்க, v1 minus v1 கேன்சல் ஆகிடும். லெஃப்ட் சைடில் 3 times v2 வரும், ரைட் சைடில் 3. ஸோ v2 எவ்வளோ 1, v2 எவ்வளோ 1. ஓகே, ஸோ v2 1 மீன்ஸ் இங்கே v2 1 சப்ஸ்டியூட் பண்ண பாருங்க, v1 plus 2 into 1 is equal to 2. அப்போ v1 ஓட வேல்யூ என்ன, 0. So அவங்க என்ன கேக்குறாங்க, what are the velocities after the collision. so எங்க தெரியுமா, we have to remember the order also. ஏன்னா first நம்ம என்ன மென்ஷன் பண்ணணும், we should mention v1 first 0, அதுக்கப்புறம் we should mention v2. order is also important. so what is the answer, v1 will be 0, அதுக்கப்புறம் v2 will be 1. so பாருங்க, the correct answer is what, option A. இல்லைன்னா what is the correct answer for this, option A. so எங்க என்ன தெரியுமா, we have not gone by the formula method. அப்படியே அந்த ஃபார்முலா வச்சுட்டு you can get the answers, v1 and v2 we can find out. இங்க என்னது, we are going with the original method. what is the original method, ரெண்டு ஈக்குவேஷன்ஸ் வரும் நமக்கு. என்னது, the conservation of momentum equation ஒன்று, ரெண்டாவது coefficient of restitution formula. ஓகேவா, so next என்னன்னா perfectly inelastic collision in the head on type. இது என்ன, the kinetic energy loss is going to be maximum. அதுதானா, இது எப்போ நடக்குது தெரியுமா, when after the collision both the particles are sticking and moving together with a common velocity. அந்த ஒரு particular situationல we will have the kinetic energy oda loss will be what, maximum. ஓகேவா, so when you will have in case of a head on collision la, when the kinetic energy loss is going to be maximum. எப்போ maximum இருக்கும், when the two objects collision க்கு அப்புறம் they are sticking and moving together. அப்படி மூவ் பண்ணா then the kinetic energy loss will be what, maximum அந்த particular scenario. so that is what we are going to take as perfectly inelastic collision. இதுக்கு இன்னொரு பேர் இருக்கா, what is it, plastic collision னு சொல்லலாம். you can also call it by the name plastic collision. ஓகேவா, இப்போ பாருங்க, we can find what is that common velocity value. எப்படி தெரியுமா, straight away use the conservation of momentum principle. so what is the initial momentum, m1 u1 plus m2 u2 is equal to final momentum. means both are moving with the common velocity v தானா, the v common னு சொல்லலாம், or we can say simply v. both are moving with the same common velocity v. பாருங்க, what is it, m1 u1 plus m2 u2 by m1 plus m2. இதுதான் common velocity. this is what is the common velocity. okay, so in the particular case என்ன தெரியுமா, they can ask us two types of questions. either they can ask us what is the final common velocity அப்படி கேட்கலாம். Otherwise they can ask us what is the loss of kinetic energy. Loss of kinetic energy எப்படி வரும்? You have initial kinetic energy. What is it? Half m1 u1 square plus half m2 u2 square. இதிலிருந்து we have to subtract the final kinetic energy. So என்னது loss in kinetic energy and சொன்னா what is it? Initial kinetic energy இலிருந்து we have to subtract the final kinetic energy. What is the final kinetic energy? Both are moving like with same velocity தானா? So what is the final kinetic energy value? அது எவ்வளவு? Half times of m1 plus m2 into the v square. The v is the common velocity. Okay va? So then we'll have two types of questions. One is they can ask us to find and the common velocity find out பண்றது ஒரு type of question. Second then after you find that common velocity அதுக்கப்புறம் we will be able to find what is the loss of kinetic energy. ஏன்னா the significance of this perfectly inelastic collision is what? Loss of kinetic energy is going to be maximum. Okay, அதுதானா? So adala you can find out what is the loss of kinetic energy value also. Okay, so this is about the perfectly inelastic head-on collision. ingane theriyuma if you want to talk about the coefficient of restitution paranga, what will be the coefficient of restitution? Collision ku appuram they both are sticking and moving, appo enna v1 oda value is equal to v2, that is what we are calling as the common velocity. What is the coefficient of restitution formula? v2 minus v1 by u1 minus u2 dana, relative velocity of separation after a collision by relative velocity of approach before collision. So v2 minus v1 it will be 0. So in case of a perfectly inelastic collision or a plastic collision, what is the value of the coefficient of restitution? We see here it is what? 0. Okay, already நம்ம ஒரு பாயிண்ட் சொல்லிருக்கோம். What is it? The coefficient of restitution or significance, right, will be there only when we are discussing about the head on type of collision. Okay, matta oblique collisions la idoda significance andha அளவுக்கு இருக்காது. The significance of the coefficient of restitution will be more in the case of the head on collision. ஏன்னா in the case of the head on collision between two bodies, right, the velocities will be along the center to center line, because the impact, right, will be along the center to center line. Velocities also will be in the same direction. So idilendi we will be able to exactly measure what is the impact of the collision on the velocities of the particles. Okay, so kinetic energy loss, right, we can also get it from the previous formula. Already nam in the inelastic collision case la we have got the expression for the loss of kinetic energy. Namakka is the formula. What is it? Half times m1 into m2 by m1 plus m2 into 1 minus e square into u1 minus u to the whole square. இதுதான் நம்ம கிட்ட இருக்க ஃபார்முலா. இதுல என்ன தெரியுமா, வெறும் இந்த e மட்டும் நம்ம 0 பண்ணா that is what is our perfectly inelastic. அதுதானா? e 0 பண்ணா என்ன வரும் பாருங்க. What is it? Half times m1 m2 by m1 plus m2 into u1 minus u to the whole square. This is what is the formula for when only you can remember this. Okay, what is it? Half times m1 m2 by m1 plus m2 into u1 minus u to the whole square. Okay, wow, this is what? This is the loss of kinetic energy in case of the, what is it, the perfectly inelastic head-on type of collision. But better thing enna theriyuma, we will go by the original approach. ஏன்னா easy ah நம்ம அந்த v common calculate பண்ணலாம். What is the v common? m1 u1 plus m2 u2 by m1 plus m2. இதுல ஒரே விஷயம் என்ன, we have to remember that this is to be calculated by using the sign convention. The velocity is different direction in the, we have to take them as what? ஒரு direction நம்ம positive எடுத்தா இன்னொரு direction we have to take them as what? Negative. Okay வா? So v common நம்ம first calculate பண்ணலாம். v common வந்ததுக்கு அப்புறம் we will be able to calculate what is the loss of kinetic energy. ஏன்னா நிறைய formulas நம்ம memorize பண்ண முடியாது. ஓகேவா? So அதனால better thing என்னன்னா go with that original approach. Both in case of the general inelastic, அதுலயும் அது the best method. Go with the general approach, which is what? Take the conservation of momentum principle, அதுக்கப்புறம் use the coefficient of restitution formula. அதுல இருந்து we can solve the problem. இங்கேயும் அப்படிதான், we can use what? The common velocity first we can calculate. அதுக்கப்புறம் using that we can calculate what is the loss of kinetic energy. Okay, பாருங்க, these are the kind of questions we can expect. Two masses. another 8 kg mass having a speed of 10 meter per second, 2 kg mass 5 meter per second, moving along the positive x-axis, means both are moving along the same direction. பாருங்க இதனது 10 meter per second, அதுக்கப்புறம் 2 kg is moving with 5 meter per second. ஓகேவா? undergo perfectly inelastic collision, means collision க்கு அப்புறம் they both will move together, அப்படிதானா, with a common velocity. பாருங்க what is it, 8 plus 2 எவ்வளவு 10. what is the kinetic energy loss in the collision? இந்த collisionல what is the kinetic energy loss? first நம்ம என்ன calculate பண்ணோம், the common velocity calculate பண்ணோம். what is it? இதனது particle 1 ன்னு எடுத்தா this is particle 2, m1 u1 8 into 10 80 plus m2 u2 2 into 5 10 divided by m1 plus m2, இதனது 80 plus 10 90 by 10, what is it, 9 meter per second. that is our common velocity. அதுதானா? loss of kinetic energy சொன்னா what is it, initial kinetic energy half into m1 into u1 square plus half into m2 into u2 square minus half into, finally it is like a combined mass dana, and the mass value of 10 into velocity another 9. so this is the initial kinetic energy of both the particles. Adilandi we have to subtract what is the final kinetic energy of the combined mass. okay va? so ipo parunga what is it that we are getting, enna varudhu parunga, and value appadi nama simplify pannum. see we can solve these kind of questions so easily without remembering the formula. and nama formula remember பண்றதுக்கு if you are trying it right, there may be chance of making a mistake. inga parunga 2 ones are 2 fours, so 4 into 10 square evla, that is 400 plus 2 to cancel out, 5 square 25 minus 5 into idanadi 9 square means 81 dana, so 425 minus idanadi parunga 405, 81 into 5 evla, that is 405. so we'll get 425 minus 405 means 20. everything is in the SA system, right? so the loss of kinetic energy will be in terms of joules. Then what is the answer for this, 20 joules. okay, so maybe better thing enna, you try to solve these problems by using those general approach. the formula illama we can solve it by using the general approach. okay va? so this is about the loss of kinetic energy in case of the perfectly inelastic type of collision. okay, so அடுத்த question பாருங்க, two masses 6 kg and 4 kg. 6 kg oda speed enna 8 meter per second, 4 kg 2 meter per second, moving along the positive x-axis and negative x-axis. inga difference irukka, what is it parunga, 6 kg நம்ம particle 1 ன்னு எடுத்தா it is moving towards the positive x-axis, but 4 kg அப்படி கிடையாது, it is moving towards the negative x-axis. okay, so we have to use the sign convention part. inga we have to use the sign convention. so parunga what is the general, right side நம்ம positive ன்னு எடுத்தா left side என்னது negative. okay va? so inga parunga this is u1, so u1 will be taken as what, 8 meter per second, but u2 as per the sign convention, right, இது எப்படி minus 2 நம்ம எடுக்கணும். okay, so common velocity formula enna, m1 u1 6 into 8 48 plus m2 u2 4 into minus 2 வரும், sign convention use ஆகும், divide by m1 plus m2, 4 plus 6 எவ்வளவு 10. பாருங்க 48 minus 8 எவ்வளவு 40, 40 by 10 means 4. so common velocity எவ்வளவு 4 meter per second. அங்கல இருந்து we have to calculate what is the loss of kinetic energy. loss of kinetic energy and what is it, initial kinetic energy half into 6 into 8 square plus half into 4 into 2 square. நீங்க ஒன்னு அப்சர்வ் பண்ணுங்க, மொமெண்டம்ல அந்த சைன் கன்வென்ஷன் வரும், பட் கைனடிக் எனர்ஜில அந்த சைன் கன்வென்ஷன் கான்செப்ட் வராது. ஏன் தெரியுமா? the kinetic energy is what, it is a scalar quantity. velocity நம்ம ஸ்கொயர் பண்ணா even the minus will become what, plus. the sign convention concept will not be there for the kinetic energy part. ஏன்னா kinetic energy is what, is the scalar quantity. so initial kinetic energy எவ்வளவு, half into 6 into 8 square plus 4 kg oda kinetic energy எவ்வளவு, half into 4 into 2 square. அதுல இருந்து we have to subtract the final kinetic energy. finally both of them 6 plus 4 10, it's like a 10 kg mass moving with what, 4 meter per second velocity. so half into 10 into 4 square வரும் அதுதான். so இங்கிருந்து we will be able to see what is the என்னது பாருங்க what is the loss in kinetic energy பாருங்க what is it இது என்ன 2 1s are 2 3s are so 3 into 8 square எவ்வளவு 64 plus 2 1s are 2 2s are 2 into 2 square means 8 இது என்னது minus okay subtract பண்ணுங்க so 5 into 4 square பாருங்க 3 into 64 means இது என்னது 192 plus 8 minus இது என்னது 4 square means what 16 okay 16 into 5 எவ்வளவு 80 so 200 minus 80 அது என்னது 120 joules. This is the loss of kinetic energy. நீங்க ஒரு விஷயம் அப்சர்வ் பண்ணலாம் what is it in the previous case ல என்னது both the bodies are moving in the same direction both of them are moving in the same direction அங்க பாருங்க what is the loss of kinetic energy கம்மியா இருக்கு 20 joules but இங்க என்ன வருது when they are moving in the opposite direction ல வந்து collide ஆகும்போது what is it we are having the loss of kinetic energy to be a higher value see perfectly inelastic and சொன்னா for the given type of collision we are going to have the maximum kinetic energy loss but adula theriyuma if the bodies are moving in the same direction before the collision means generally adula kinetic energy loss kammiya irukum but if the bodies are moving in opposite direction vechukonga then the kinetic energy loss will be நம்ம இங்க பார்த்த மாதிரி kinetic energy loss will be what higher value okay va so இப்படிதான் we have to approach these problems இதுல இன்னொரு special scenario என்ன தெரியுமா நீங்க பாருங்க if you are having a mass m which is having a velocity v towards the right side அந்த மாதிரி identical mass m which is moving towards the left side with a velocity v இப்ப பாருங்க what is the common velocity after the collision m1 u1 so இங்க பாருங்க u1 இப்போ say for example right side நம்ம positive எடுத்தா left side will be what negative u1 என்னது v ஆ நம்ம எடுக்கணும் u2 will be what left side இருக்கா so we have to take it as what minus v so பாருங்க m into v minus m into v divided by m plus m what is it 0 தானா so collision க்கு அப்புறம் அந்த ரெண்டு ஆப்ஜெக்ட்ஸோட சிச்சுவேஷன் எப்படி இருக்கும் அப்படியே ஸ்டக் ஆயிடும் so collision க்கு அப்புறம் என்ன they will just come to rest அவ்வளவுதான் collision க்கு அப்புறம் they both will be just coming to rest okay va so this is about the special case of a perfectly inelastic head on collision okay so with that we have concluded the discussion about the head on type of collision so head on நம்ம என்ன பார்த்திருக்கோம் we started with the perfectly elastic in the head on அதுக்கு அப்புறம் we talked about the special cases in that then we have gone to the inelastic okay அதுக்கு அப்புறம் we have come to the perfectly inelastic collision in the head on category okay next session என்னன்னா we will start with the oblique okay so we will start with the oblique type of collisions